This is Aiming for a 9 Spring 2020 practice. It's paper 2 higher, and this is a continuation from the paper 1 that I did last time. That's on the channel if you want to watch it. The equation of a curve is y equals a to the x. A is the point where the curve intersects the y-axis, and state the coordinates of a. Well, if you think about the y-axis, every point on the y-axis occurs when x is equal to 0. So no matter where you are on the y-axis, x will always equal 0. And so we can use this equation by plugging in x equals 0 to find out what y equals. Okay, so if we plug in x equals 0, we'll get y equals a to the power of 0. And anything to the power of 0 is just 1. So y equals 1. So x equals 0 and y equals 1. So 0, 1. The equation of a circle C is this. The circle C is translated by the vector 3, 0 to give circle B. Draw a sketch of circle B and label the center of the circle and any points of intersection with the x-axis. Okay, well, we know that the form of a circle is x squared plus y squared equals the radius squared. So 16 equals radius squared. So the radius equals 4. And in this form here, the center is 0, 0. So whenever it's x squared plus y squared equals something, the center is always 0, 0. Okay, so if we draw it like this, with a radius of 4, so it goes 4 to the right, 4 to the left, from 0, 0. And we also have to label 0, 0 here. You don't need to label anything in the y-axis because the question doesn't want that. Okay, so that's circle C, not circle B. Now, we want to translate this 3 to the right. That means all the x coordinates are going to increase by 3. So minus 4 plus 3 is minus 1. 4 plus 3 is 7. But be careful here because the center will also increase by 3 as well. So the center will be 3, 0. Okay, so if we redraw that, this has gone from minus 4 to minus 1, from 4 to 7, and then from 0 to 3. And that's your new circle. Here is a speed time graph for a train. Work out an estimate for the distance of the train, travelled in the first 20 seconds. Use 4 strips of equal width. Okay, well, in the first 20 seconds is from here to here. And this is called the trapezium rule, these types of questions. I'll show you why in a second, but just draw down some strips. So one here, here, here. I'm connecting them as well as I'm going across. So it's like this. So draw the strips, because we have 1, 2, 3, 4 of equal width of 5, and then just connect them. And because this is a speed time graph, the area under the curve is equal to the distance travelled. Okay, so we want to find what this area is here. Here, 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 and here, and we want to add it together. Well, the area of this is easy because it's a triangle, so it's half base times by height. The base is 5, and the height is 2. So that's just 5. Is the area for that. Now this one, you could split this up into a rectangle here, and then a triangle here, and then add the two areas together. Or if you notice, because if you remember I said this was called the trapezium rule, this is actually just a trapezium. Where this side is A, this is B, and then this is the height H. So it's just a trapezium flipped on its side. And this is the area, this is the formula for the area of a trapezium. I think you get given this in the formula book. So this length, add this length, divided by 2 times by this height, which is 5, because 10 take away 5 is 5, gives you that area. So it's 2 plus 5 divided by 2 times by 5, which gives you 35 over 2. Okay, you do the exact same thing, and then for this one. So here we've got 5 plus 10 divided by 2 times by the height here. So 15 take away 10 is 5, so the height here is also 5. And then that gives you 75 over 2, which you can put there. Same thing. 10 plus 18 divided by 2 times by the height, which is 5, because 20 take away 15 is 5. You'll get that, Evaluate. You've got a calculator, remember, so you can just put this into a calculator. And then, yeah. And then if you want the area under this curve here between 0 and 20, we'll just add these together. So this plus this plus this plus that. And that will give you 130. And that's the distance traveled. Now the question says, is your answer to part A an underestimate or an overestimate of the actual distance the train traveled? Well, if you look at this, the trapezium actually goes above the curve. So when we calculated these areas, we actually calculated a bit too much. We calculated this small bit in between as well. And this means that it's an overestimate because we've calculated a tiny bit more. So you have to say an overestimate because the trapezium extends above the curve. At time t equals 0 hours, the tank is full of water. Water leaks from the tank. At the end of every hour, there is 2% less water in the tank than at the start of the hour. So that tells us if we have 2% less and we had 100% to start off with, then every single hour we only keep 98% of our amount. Okay, and that'll be important. The volume of water in liters is given with this, and given this, write down the value of K. Well, you can imagine this is at 0 hours. So when we've just put it in, we've got 2,000 liters, or whatever the unit is. We'll say liters. So we have 2,000 liters of water right now. And the next hour, this VT is this part. Okay, so that you can read this as the amount right now added by the amount next will equal this. Okay, or this amount equals this amount. Well, the next hour equals the hour previously multiplied by K. Okay, so 2,000 multiplied by K gives you this. So at 0 hours we have 2,000, and then the next hour we only keep 98%. So this as a multiplier is 0.98. So we do 2,000 multiplied by 0.98. Okay, and that will give you 1960. And well, if you notice, well, each time we're taking the volume, the new volume, which is VT, and we're multiplying it by some amount. And if we know we're only keeping 98% each time, then each time we're only multiplying it by 0.98. That means that K must equal 0.98. Question 4. OAC is a sector of a circle, center O, radius 10. BA is the tangent to the circle at the point A. BC is the tangent to the circle at point C. Angle AOC is 120 degrees, and you want to find this area here, the shaded region. Okay, well, if BA and BC are tangents, that means that these are 90 degrees, because a tangent meets a radius at 90 degrees. Okay, and if we want to find this shape here, the area of this shape here, well, we can find the total area and take it away from the area of this sector. Okay, so we just need to find the total area. So the total area, well, what we can do is, if we put a line down the middle like this, then we've created two triangles that are congruent, and they're right angled triangles, which means it's a bit easier for us to work with. Okay, and this is 10 meters because it's the birth radii of the circle, and then this we split from 120 degrees to 60 degrees. Okay, so we have a right angled triangle with 60 degrees and 10 meters, and we want to find what this is, because if we can find this, then we can use half base times by height. Okay, so we can use SOHCAHTOA. And then we have opposite and adjacent, so TOA, T-O-A, is opposite over adjacent, so tan of 60 is the opposite over adjacent, so opposite over 10. Multiply by 10 on both sides to get 10 tan 60 equals opposite. You can put this into a calculator, or you can know that tan 60 is equal to root 3. So that this is 10 root 3 for this height here. And you might be able to just spot that this is actually, this triangle here is congruent to this one. Because first of all, they've got the same length here. And then they've got the same angle here, 60 and 60. And they share this edge. So it's side angled side congruency. It's also side, side, side congruency, and angle, angle, angle congruency, I believe. But yeah, the most easiest one to spot is side, angle, side, which means if we work out the area of this one triangle here, we can just double it to get the area of this one as well. So half base times height, so half, 10, multiplied by 10 root 3. That's also 10 root 3. And then that gives you 50 root 3 for the area of this triangle. And now we want to double it to get the area of these two triangles together to give 100 root 3. Now we've got this full area now, and we want to take away this area here, this sector. So then we'll be left with this. So the area of the formula for the area of the sector is the angle of the sector over 360 degrees multiplied by pi r squared. So the angle is 120 divided by 360 multiplied by pi, the radius, which is 10 squared. And if you put that into a calculator, you'll get 100 over 3 pi. So now let's do the total area, which is 100 root 3. Take away the area of the sector, which is this, to give us the area of the shaded region. And if you put that into a calculator, you'll get 68.5 meters squared to 3 significant figures. Sketch the graph of y equals tan x. Okay, so tan x, you should have a rough idea of what it looks like, and you should know your exact values up to 90 degrees. But there's a special property of the tan graph, and that is that it repeats every 180 degrees, and that'll be relevant later. Anyway, so tan of 0 is 0. You should kind of know that as an exact value. And then if you recall what tan looks like, it goes like this. Okay? But we also know that there's an asymptote at 90. So if you use your exact value table, or your hand trick if you prefer to use that, or any other methods, well, you'll notice that tan of 90 doesn't have a value because it's undefined, because you'd be divided by 0 otherwise. So there is actually no points of intersection here. So we're getting this across the y-axis, we're getting higher and higher and higher, and we're getting really close to 90 degrees, but we're not actually touching 90 degrees. So you have to draw this asymptote here to show that we never actually touch 90 degrees. Okay, and now, you know what? Actually, now that I've thought about it, you've got a calculator, so you can just put in tan of 20 degrees, 40 degrees, 60 degrees, 80 degrees, and then just plot about where it is. So if, say, tan of 30 degrees is root 3 over 3, then you'll know, oh, well, it's probably somewhere around here. And then plot tan of 80 degrees and think to yourself, oh, well, it's somewhere around here. And then just keep on doing that. So do a couple values. Put into your calculator, well, 90 will give you a math error. So put in tan of 100 degrees maybe, and that'll give you somewhere down here. 120 degrees, 150 degrees, well, 180 here, sorry. And then just keep on doing that. And you'll notice that, well, we don't have an answer at 270, so that's another asymptote. And do the same thing here, but be careful, because we only want to go to 360, so we don't want to go higher. So we'll end there. And I've just gotten this picture online of it because I can't really draw it on PowerPoint well, but this is roughly what it should look like. And, well, we can, if you remember last time I said that the tan graph repeats every 180 degrees. And what I meant by that is, well, this point here, if you add 180 degrees to it, it's the same as this point here. And if you add 180 degrees to this, it's the same as this point there. Similarly, this point here, if you add 180 degrees to it, it's the exact same as this point. Add 180 degrees to this point, it's the same as this. Add 180 degrees to this point, it's the same as this. Also, if you add 180 degrees to the asymptote, you'll get the next asymptote. If you add 180 degrees to this asymptote, you'll get the next one, which is at 450 degrees. And so that can roughly help you. So you know that if you're starting off like this, then your graph will also have something like this, starting from 180. And then you'll know to go back as well. Write this as a single fraction, and then work out the value of a and b. Okay, so what we want is to put them over the same denominator. We want a common denominator, so we can group it together and then expand. So multiply this one by x plus 3 over x plus 3, and then multiply this one by x minus 3 over x minus 3. And now just be careful, you do not want to put these together because we've got a 2 minus the fraction. and this minus is only applying to this fraction here. Now, I've said here, well, if you put it together like this, now the minus is applying to the two fractions together, and this is incorrect because that's not what the question wants. So this is wrong. You cannot do this. So if you've gone wrong somewhere and you don't know why, it could be that. What you need to do is change this 2 so that it has the same denominators as all of these. So multiply it by x plus 3 over x plus 3, and then x minus 3 over x minus 3. So now they all have the same denominators, and now you can group them all together. Because the difference between, I've not actually grouped the last one, but you can just group it all together to get this. So it's this, take away that, take away that. So it's this, take away that, take away that. But the problem with this one was it was just this, take away that. It wasn't this, take away that, take away that. So now this, we can just expand it. So you'll have x squared minus 9. You'll have x squared plus 5x plus 6, and x squared minus 9x plus 18. And then expand the 2 here to get 2x squared minus 18. And now what you want to do is just be careful, because you have a minus sign here. You can think of this minus, remember, keep the brackets, you need the brackets. So you can think of this minus sign as minus 1. So you want to times everything inside the bracket by minus 1. Same here, everything inside the bracket multiply it by minus 1. That'll give you minus x squared, minus 5x, minus 6. But it gives you minus x squared, and then minus 1 multiplied by minus 9 is positive 9x, and then minus times by 18 is minus. So this 9x actually becomes positive, because a minus multiplied by a minus is a positive. And now you can just take away normally. So minus x squared add minus x squared is minus 2x squared, minus 2x squared add 2x squared cancels, and then you have minus 18, minus 6, minus another 18, that's minus 42. You have a calculator, so you can do it on that. And then you have minus 5x and positive 9x, which is 4x. So you have 4x minus 42 over x squared minus 9. Now it's in the form that it wants it now. So just say, well, what's next to the x? That's a. What's next to the x here? That's 4. So a equals 4, and b here is minus 42. Work out the exact value of x. Questions like this, what you want to do is have the same base. If you're looking for x and x is a power, then you need to somehow make all of these the same base. So 16 is actually 2 to the power of 4. And 8 is the same as 2 to the power of 3. And I want you to put that in brackets because that'll be important later. So like this. This is the exact same as this, but now it's raised from the power of 2. Okay, so you have 2 to the 4 to the power of 1 over 5, 2 to the power of 3 to the power of 3 over 4. And when you have powers like this, you can just multiply them. So 4 times by 1/5 is 4 over 5, and then 3 multiplied by 3/4 is 9 over 4, like that. You should know these from your indices laws. And then once you've got something like this, same base, you've got a multiply symbol here. That means you're adding the powers. So it's 4/5 add x equals 9 over 4. Okay, you're just equating the powers. So 4/5 plus x equals 9 over 4. Then just take away 4/5 from both sides to get x equals 29 over 20. The distance time graph shows information about part of a car journey. Use the graph to estimate the speed of the car at time 5 seconds. Okay, well, speed we know is distance divided by time. So we want the y-axis, because distance is on the y-axis, divided by time on the x-axis. And hopefully that should be hinting at you, well, y divided by x is like changing y over changing x, which hints at us that we need to use the gradient at time t equals 5. So at 5, draw yourself a gradient like this. Okay, that just touches the curve at one point, and do change in y over change in x. So up it goes, what is that, 76? Yep, so from 0 to here is 76, and then it goes from 3.2 to 8. So 8 take away 3.2 is 4.8, so it's 76 divided by 4.8, and that will give you 15 meters per second. Here are two similar solid shapes, A and B. The surface area of shape A to the surface area of shape B is in the ratio 3 to 4. The volume of shape B is 10 centimeters cubed, work out the volume of shape A. Now, if you notice here, they've given us the surface area, but they want us to work out the volume. But so what we need to do is somehow turn the surface area into the volume. And well, if you think of it like this, the area scale factor from A to B is in the ratio 3 to 4. Okay, so that means you have to multiply A by 4 over 3 to get B. Okay, because the ratio 3 to 4 means 3 over 4. Okay, so 3 multiplied by 4 over 3 gives you 4, which is B. Okay, so A multiplied by 4 over 3 gives you that. So the scale factor there is 3 over 4. Oh, no, wait, sorry, yeah. No, ignore that what I just said, but just know that the scale factor is in the ratio 3 to 4 of the area. Now, the length scale factor is the square root of the area scale factor. So square root this. So the square root of 3 is just square root of 3. The square root of 4 is 2. We're only taking the positive answer because we're thinking about lengths and areas and volumes, and you cannot have them be negative. Now we've got the length scale factor. If we cube this, now we'll get the volume scale factor, because that's how it works. So if you cube this, so root 3 cubed is, if you put it into your calculator, is 3 root 3, and 2 cubed is 8. So you'll have 3 root 3 to 8. And now if you notice here, B is 8 here, but the question is telling us that it's 10. So how do we turn this 8 into a 10? Okay, so the volume scale factor is this. Well, how do we go from 8 to a 10? Well, you just multiply by 10 over 8. And if you can't think of why that is, then think about it this way. 8 multiplied by some number, which we'll call x, gives us 10. So if we rearrange for that some number, we'll get 10 over 8. Okay, and that simplifies to 5 over 4. So 8 multiplied by 5 over 4 gives us 10, but because this is in a ratio, we need to keep it in the same proportion, so we need to multiply this one by 5 over 4 too. So 5 over 4 multiplied by 3 root 3 is 15 root 3 over 4. That should say 10, by the way, not 8. That is incorrect, that should say 10. So 15 root 3 over 4 to 10. So the volume of shape A is 15 root 3 over 4, which is 6.50 centimeters cubed to 3 significant figures. You do need the 0 at the end because it says 3 significant figures. When a buyer's coin is thrown 4 times, the probability of getting 4 heads is 16 over 81. Work out the probability of getting 4 tails when the coin is thrown 4 times. Okay, well, we know that the probability of head, so 4 heads in a row, is 16 over 81. And this is just h to the power of 4. So if we take the fourth root of both sides, the fourth root of 16 is 2, the fourth root of 81 is 3. Okay, so the probability of 1 head is 2 over 3. Because if we take the fourth root of this, we'll get 1 head. Fourth root of that, we'll get 1 head probability, which is 2/3. Now, if the probability of getting heads is 2/3, the probability of getting tails is 1 minus 2/3, and that is 1/3. Now, the probability of t to the power of 4, so tails, is this all to the power of 4. So 1 over 3 to the power of 4 is 1 over 81, and that is your answer. A, B, C, and D are 4 points in the circumference of a circle. AEC and BED, straight lines, prove that triangle ABE, and triangle DCE are similar. Now, it doesn't say congruent here because lots of people will try and look for how to prove that they're congruent. But what you need to just notice here is that for 2 triangles to be similar, they need the same angles. So they need angle congruency. So if you have angle congruency, it means the 2 triangles are similar. Because if you just sit there and think about it for a couple of minutes, or maybe go on GeoGebra or just draw random triangles, you'll notice that if you have the same angles, then they'll always be the same length, which means that they're similar. Okay, so we can also say, that's jumping ahead of myself. We can say that angle ABD, so ABD, and angle ACD are the exact same. And it's because, well, if you look at this is an arc, and we're forming an angle from the arc. Here, from that same arc, we're forming another angle that means these two are equal, because the circle theorem here is angles subtended from the same arc are equal, and I'll show that. I'll write the reasons at the end. Okay, so angle ABD equals angle ACD. And now they've actually used the same circle theorem twice, because if we look at the arc BC now, angle BAC is equal to angle BDC. Okay, so it's the same arc, we form this angle here, and the same arc we form this angle here, which means that these angles are exactly equal to each other. So we can say that, and then give you a reason. So angles subtended from the same arc are equal. So now we've got angle, 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 and we still need these two angles to be the same. So the circle, what you need to say here is that vertically opposite angles are equal. And just look at that. So this angle is vertically opposite this, and if you have vertically opposite angles, that means they're equal. So angle DAC is equal to angle AEB. Okay, and say vertically opposite angles are equal, and then say they are congruent via AAA symmetry, via AAA congruency. Therefore, they are similar. If you don't know what these three dots are, it just means therefore. It's just a quicker way of writing it. The nth term of a sequence is 2n squared minus 1. The nth term of a different sequence is 40 minus n squared. Show that there is only one number that is in both of these sequences. Now, the easiest way to do this question is just write out the sequences. So plug in n equals 1, n equals 2, n equals 3, n equals 4, n equals 5 to get this sequence here that you formed. And do the same thing for the second sequence. And we're saying that there's only one number that is in both the sequences. Let's check. So 31 and 31, they're both in the sequences, and that's the only one. Now, if you look at this sequence, it's going up. So we've got 1, 7, 17, 31, 49. It's going up constantly. But this sequence is going down. And if this sequence is increasing and this one's decreasing, and they've only intersected once, and if you look at this, like their starting points, their ending points, so this one will never be 39, and it's just going to go past it. So this will always go to this will get higher and higher and higher, but this one will get lower and lower and lower. So that means they're going in different directions. So if there is an equal number in both of them, then it's the only one, and that there will not be any other numbers in both sequences. Remember, that's therefore. Triangle A is transformed by the combined transformation of a rotation of 180 degrees about the point -2, 0, followed by a translation with vector -3, 2. One point on triangle A is invariant under the combined transformation, and find the coordinates of this point. First of all, an invariant point. What invariant means is a point that after you've translated it or moved it about however, it maps back onto the original shape. So the point basically hasn't moved at all. Okay, and you'll see what I mean in a second. So let's rotate 180 degrees around -2, 0. Use tracing paper for this, and you'll get this. Okay, and now we want to translate by this. So we're going 3 left, 2 up. So 3 left, 2 up will get us here. Now here you might be thinking to yourself, well, there's 2 invariant points, this and this. But that's not the case, because if you think about it, if we've rotated this 180 degrees, this point here, it's actually here now. Okay, so this point is not the same as this point, but this point is actually this point. Okay, so the point here on A, on triangle A, is equal to this point here on the new triangle, and this point here on A is the same as this point here on this triangle. So they've actually like swapped around the points. It's like you've just reflected it down this line here. Okay, so this point has swapped to this one, and this one has swapped to that one. Meaning the only point that hasn't changed is the one directly in the middle. Because even if you flip that point in the middle, it's just going to stay in the same place. So you have to say that the invariant point, the point that hasn't changed places, is -3.5, 1. Here are 2 right-angled triangles. given that tan E equals tan F, find the value of X. You must show all your working for 5 marks. Okay, so tan E, they've given us a clue here. We're using tan. So the angle is E. So tan E equals, well, we know that tan is opposite over adjacent. So tan E equals X over 4X minus 1, because this is opposite, this is adjacent. Okay. Now tan F is, well, the angle is F, opposite over adjacent. So tan F equals 6X plus 5 over 12X plus 31. And the question says these are equal. So let's make them equal to each other, like this. And now we can solve this for X. So if you multiply by 12X plus 31 on both sides and 4X minus 1 on both sides, you'll have 12X squared plus 31X equals, and then this double bracket here. And this gives you, if you just go slowly, you'll get 24X squared plus 14X minus 5. Okay, and now rearrange to have 0 on one side to get this. And what I would recommend doing here is, because this is a calculator paper, just put this into your calculator. Use the quadratic formula if you want, or, you know, because I feel like that's the easiest way. You can actually factorize this. You can use the AC method. I'd recommend that you search up what the AC method is for factorization, because it's very useful, and I think it just makes it very easy. So you do, yeah. Or yeah, just put it into a quadratic formula. Anyways, you'll get this if you factorize it, but if you put it into the quadratic formula, you'll just get the answer straight away. So then here, X must equal, if this is 4X minus, if this is 4X plus 1 equals 0, then 4X equals minus 1, so X equals minus 1 over 4. 3X minus 5 is equal to 0, so 3X equals 5, and then X equals 5 over 3 as your two solutions for X. And now it says value of X. This is not plural, this is singular, and that's a clue. So it's saying that we only need one of the answers. And if you just look at this, well, we can't have a minus a quarter as the length, because you can't have a negative length. Because if you just think about it, you can't like comprehend what a negative length is, unless you're, say, defining a direction and saying the negative is in the other direction. But in this case here, we cannot have a negative length. So you'd say, you have to say this, you have to cross out that solution there, but you don't have to cross it out. You just say, cannot have a negative length, so X must equal 5 over 3. The diagram shows 3 identical circles inside a rectangle. Each circle touches the other 2 circles and the sides of the rectangle as shown in the diagram. The radius of each circle is 24 millimeters. Work out the area of the rectangle. Okay, so it's a rectangle, so you do base times by height. Okay, or length times by height, or length times by width, whatever you call it. So the length here, well, we'll look for the length later, but the height is actually the harder part to find, because some people will say, well, this is one radius, this is another radius, and then this is another radius from here to here, and then this is another radius. So it's 4 radiuses high. But that's actually not right, because if you think about this, a radius from here to here, if you bring that across, you'll notice that it only goes to here. And if we're adding this radius here now, we've added this extra part here. So this is incorrect. We can't do this. So what we need to do instead is draw a triangle here in the middle, because we know from here to here is 1 radius, or from here to here is 1 radius, and then from here to here is 1 radius. So the radius plus the height of this triangle gives us the total height. Okay, we're told that these are identical circles, and so the radius of each one is 24. So this has a radius of 24. So let's just draw this radius on. This is equal to 1 radius because it's here to here, but I've just moved it here to here, and then the same one here. Okay, and if this is 1 radius 24, and this is another radius 24, this full side is 48. And because these are all identical, so this one's also 48, and this one's also 48. And now if we split this down the middle, because if we do that, then we can get a right angle triangle, and then we can use Pythagoras to work out the length of this leg here. So if we split this down the middle, draw the triangle to the side. Now it's not 48 here, it's half of it. We split it down the middle, so it's 24 here, and then here this is the same, so this is 48. And now use Pythagoras, so this squared plus this squared equals this squared, or the square root of this squared plus this squared gives you this. Either way, it gives you the same answer. So a squared plus b squared equals c squared. So that means the height here is 24 root 3. So 24 root 3 is this height here. This is 24 because it's the radius, as the question tells us. And this is also 24 because it's the radius, as the question tells us. So the height is 24 plus 24 root 3 plus 24. Simplifying your calculator, you'll get this. Okay. Actually, it's probably best not to put it into a calculator, but you can if you want. And now we need the length across the bottom. The length is easy to figure out because it's one radius, so that's 24, plus another radius, that's another 24, plus another radius, that's 24, plus another radius, that's 24. So that's 4 radii, so 24 times by 4 is 96. And then that's 96 across the bottom, multiplied by the height, which is here. 96 multiplied by the height, put that into your calculator to 3 significant figures, is 8,600 millimeters squared. The diagram shows the positions of 3 towns, Acton A, Barston B, and Chorlton C. Barston is 8 kilometers from Acton on a bearing of 37 degrees. Chorlton is 9 kilometers from Barston on a bearing of 150 degrees. Find the bearing of Chorlton from Acton. So it says Chorlton from Acton. So we're starting at Acton and we're going to Chorlton. So we want the bearing. So it's this angle here. Okay. So if we just draw a line here, it's this angle. So how do we figure out this angle? Well, I'll show you how. So if you look at this line here and this line here, they're parallel. And if you remember some of the properties of parallel lines is that these internal angles, these co-interior angles, add up to 180 degrees. So that means 180 take away this will get us this angle here, which gives us 143. And angles around a point add up to 360. So this add this is 293. And the 360 take away those two angles is 67. So this here is 67. Okay, and we're looking for, from here, we want this angle here. And now what I'm actually going to do is work out this length. And I'll show you why in just a second. Because if we work out this length, then we can say this sine of this angle over this is equal to sine of this angle over this. And then we can use sine rule to figure out what this angle here is. So here, how do we work out this? Well, just think cosine rule. We've got two lengths and the angle in between. So this is cosine rule. And cosine rule you should know as this, where this is A, as we've labelled. This is B, C, and then this is capital A. So plug that in. That's A squared equals 8 squared plus 9 squared minus 2 times 8 times 9 cosine of 67 degrees. You can put this part into your calculator to get this, and then square root it to get just A, which is 9.41991. So that's this part here. Now sine rule is this. So sine of 67 over 9.41991 is equal to sine of this angle, which we'll call B, over 9. Okay, if we times this one by 9, we'll get sine by itself. And then if we do the inverse sine of both sides, or arc sine, as you might see on some calculators, you'll find what the angle B equals, and that is 61.58 degrees. So this angle here is 61.58 degrees. Now just be careful, this isn't your answer, because Chorlton from Acton is this full here, angle here. Remember, we state the angles from north. So it's 37 plus 61.58, which is 98.58 degrees, and to one decimal place is 98.6. But because it's a bearing, we always add the placeholder 0 at the front, so it's 098.6 degrees. The diagram shows a parallelogram. The area of the parallelogram is greater than 15 centimeters cubed. Show this. Okay, so to find the area of this, if you just draw this diagonal here, well, this is now split up into a triangle here and a triangle here. And think of how could you work out the area of this triangle? Well, we've got two lengths and the angle in between. So you might think half AB sine C. Half multiplied by this sine of 150 degrees. Put that in. This is minus 2x squared plus 21x minus 10, and then that's still all a half of it. And then sine of 150 degrees you might know is an exact value if you know the symmetry of the graph, but that's the same as sine of 30 degrees, which is a half. Multiply a half by a half, that's 1/4. And now we want to multiply this by 2 because that's the area for just one triangle, but we want both of them. So multiply this one by 2, and then 2 multiplied by 1/4 is just a half. And we're saying that this area is greater than 15, so just say that. And then multiply this one by, multiply both sides by 2 to get this. And then rearrange it so you have 0 is facing the greater than symbol to get that. No, that's not the final answer. Just rearrange it so that 0 is facing that greater than symbol. Oh, that's wrong. That should actually be pointed in the right direction, so it should be like this. So it should be 2x squared minus 21x plus 40 is less than 0. Sorry, I forgot to do that. And yeah, okay, so this should just be facing this way. Apologies for that. Just another quick tip here. One way that you can work out how to get from here to here without just adding 2x squared minus 21x plus 40 is you can just multiply both sides by -1. But you have to be careful because when you multiply both sides by -1, the direction of the inequality swaps. So instead of it looking left, it looks right. Okay, so this should actually be looking right. Just imagine this is looking right. So when we multiply this by -1, the direction of the inequality changes so that it's facing right like this. Same goes for dividing by -1 or any minus number. Find the range of possible values for x. It appears that I've repeated the mistake, which is not good because that means I've answered the question wrong, but it's fine. I'll tell you what the correct answer is. So factorize this using your preferred method. So you have x equals 5/2 and x equals 8. And these are your critical points. So if you draw roughly what the graph may look like, something like this, okay? And we're saying that 8 is on the right here, and then 5/2 is here. Ignore this. This is wrong because I've just done the question wrong. I've misread it. Well, actually, I've just made a small mistake. And we want to be less than 0, not greater than 0. So we want x to be between 8 and 5/2. So we want this area under the graph. Now, when is x? So x is smaller than 8, but it's larger than 5/2. Ignore this as well. Right as an inequality, x is, so you have x in the middle, and then the right is smaller than 8, but it's larger than 5/2, and that's the correct answer. I've just spotted that now, and I've forgot to check properly last time when I was creating this. So yeah, ignore this. The symbol should be facing right. The correct answer is x is less than 8, but bigger than 5/2. The diagram shows a rectangle ABDE and two congruent triangles AFE and BCD. The area of rectangle ABDE is equal to the area of triangle AFE plus the area of triangle BCD. AB to AE is 1 to 3. Okay, well, if we say that AB is just x, then AE is 3x, because it's still in the ratio of 1 to 3. And I've used x instead of 1 and 3, because we don't know what the lengths actually are. We just know it's in the ratio of 1 to 3. And this is in the same ratio, so this is fine. And because we can do this, we can work out the area of this triangle here, because it's the same thing as we saw last time. It's half AB sine C. So half this times sine of this. Sine 30 is a half. A half times 24 is 6. 6 multiplied by 3x is 18x. And that's the area of this. Now, the area of this is actually equal to the area of this. These two are congruent. You can prove that for yourself. Saying that side, angle, side, because, you know, these are the same, side, angle, side. So therefore, these are congruent. So you can just multiply this 18x by 2 to get the area of this triangle plus this triangle. So this triangle plus this triangle. And that apparently equals the area of ABDE. ABDE. And the area of ABDE is 3x multiplied by x, which is 3x squared. So 3x squared equals 36x. This plus that. I'm just going to clear something up here. So when you divide by x, what you're actually doing is you're discarding a solution, and that solution is x equals 0. Because the way that you're supposed to do this is take away 36x and then factorize it to get x equals 6, I think, or x equals, sorry, no, what was it? X equals 12 or x equals 0. But we know that x cannot be 0 because it's a length, and we're not going to have a length of 0. So here we can just divide by x, and that's fine. You don't actually need to say this in your exam. You'll still get all the marks if you just divide by x without thinking about this. But if you just wanted to know, this is what we're doing when we're dividing by x. So when we're dividing by x, we're discarding the solution x equals 0, because usually you can't divide by x. So when we are doing this, we're saying that x equals 0 is not a solution we want. So divide by x here, and then divide by 3 on both sides to get x equals 12. Oh, well, actually, no, I didn't do that, because I said, well, we want the length AE, and AE, we've said is 3x, so 3x equals 36, that's fine, that's already the answer. You can say that x equals 12 by dividing by 3 on both sides, and then timesing by 3, because 12 times 3 is 36, or you can just leave it like that, you'd still get all the marks, and that's your answer. The diagram shows a circle center O. AB is the tangent to the circle at the point A. The point B has coordinates 16, 0. The point P has coordinates 3P, P. Find the value of P to 1 decimal place. Okay, well, the easiest way we can do this is work out the formula. Sorry, work out the formula for this, the equation of this circle, sorry. And then we know that 3P and P lie in the circle, so we can sub in 3P for x and then P for y. Okay, so one way we can work out the equation of the circle is, well, if we draw the radius here from O to A, and we can do this because it's it's the same length and it's just the radius we've drawn. We can say that we know here from here to here we're going across 16. So this has a length of 16, and this has an angle of 30. And here we can use SOHCAHTOA. And we know that this is 90 degrees. That's why we can use SOHCAHTOA, because the radius meets a tangent at 90 degrees. So this is 90 degrees, so we can use SOHCAHTOA, and this is 16. Here we've got the hypotenuse, and we want the opposite. So opposite over hypotenuse equals sine 30. Sine 30 equals opposite over hypotenuse. And then times by 16 on both sides, and then put that into a calculator. Or you can say that sine 30 is a half, which you might know is an exact value that you should know, and then multiply by 16, so 8 equals the opposite. So this side equals 8, meaning the radius equals 8, because this is the radius. And that tells us that because it's centered at 0, x squared plus y squared equals the radius squared. And the radius we know is 8, so just plug in 8. So x squared plus y squared equals 8 squared, which is x squared plus y squared equals 64. We know that 3p equals x and p equals y, because this is just a point on the circle. So plug these values in. So 3p equals x, p equals y. Plug that in to get this. Expand to get 10p squared equals 64. And then divide by 10, and then square root that. And only take the positive solution, because we're saying that p is positive, because it's in the top right quadrant. So p equals 2.5. That's to 1 decimal place as well. This question is actually quite hard to show on PowerPoint, so I don't really have the best explanation. I don't really have the best visualization for it, but I think I can try and explain it. So we have this shape here, ABCD, and it's transformed by first a reflection in the line y equals x equals -1. So this line here, vertical line at x equals -1, and we want to rotate it. Now, when we rotate it, it says there are 2 vertices, so 2 points on the edge that are invariant. Okay, let's just work through this slowly. So we know that this is the line x equals -1, and we want to rotate and we want to reflect it across this. So just do this carefully. So from here to here, that's 2 gaps. So we want to leave 2 gaps here. Okay, and we'll draw the we'll draw the square here. Okay, and now what I'm going to do is just label the points on, and ABCD, doing ABCD here is helpful, because think about this: when you're reflecting this shape, this point is going to here. This point is going to here. This point is going to here. And this point is going here. Okay, so this is C, this is D, this is A, this is B. And just stop for a second and think about that. So when we're reflecting it, these appear to have like changed, but they've not. Well, they've just reflected. Okay, and how can we rotate this shape so that, for example, for 2 points to be invariant, if you ignore this rotation, an example of this that is not a rotation is if we translated it 4 to the right. So 1, 2, 3, 4. And if we've translated it 4 to the right, AD here maps onto AD here. That means these 2 points are invariant. These 2 vertices, these 2 outer edges. These 2 outer points, sorry. Okay? And that would be a possible answer. But that's not correct in this case because we want a rotation. So what you want to do is get your tracing paper on the sheet and just pick random points of rotation. And then just try rotating it to see if CD matched with CD, or if BA matches with BA, or AD matches with that, or BC matches with that. And you'll notice that there are actually 2 more answers. But if you rotate 180 degrees around the point -1, 2, you'll see that 2 of the vertices map onto each other. So you'll get this. You'll have gotten this right. Okay, so this is your answer. You'll get 1 mark for saying rotation 180 degrees, and another mark for the where you're rotating it around. Okay, there are 2 other answers, like I said. L is the circle with equation x squared plus y squared equals 4. P is 3/2 root 7/2, and that is a point on L. Find an equation of the tangent to L at the point P. Okay, so the way that you do this, well, we know that changing y over changing x is the gradient. The gradient of the radius, so from the center 0, 0 to the radius, which is at 4, we know that it's, sorry, no, to here, from the radius of 0, 0 to this point here, which is on the circle, we know that the change in y, so root 7/2 minus 0, center, divided by 3/2 minus 0 is the gradient. If we do that, I've gotten rid of the minus zeros because minus 0 does nothing. And you've got this. You can put this into a calculator, or if you know how to work with complex fractions, you just multiply the denominator of the denominator by the numerator here to get root 7/3 as the gradient of the radius. Okay, and the gradient of the tangent, if you remember, is perpendicular to the radius. So if this is the radius and you want perpendicular, you want a perpendicular gradient, you do the negative reciprocal. So the negative reciprocal of this is -3/7. You can rationalize if you want. I don't think I bothered. And I've said, well, the equation of any line is in the form y equals mx plus c. We know the gradient m is -3/7, so we'll just put it like that. And we know it goes through the point 3/2 root 7/2. So plug 3/2 for x, root 7/2 for y to get that. Expand this to get that. Add 9/2 root 7s to both sides to get this. Collect this. You can put that into a calculator if you want, or you can just rationalize it. You'll get this. Times this one by 7/7 to get 7 root 7/14 plus 9 root 7/14. Simplify that to get 16 root 7/14, which is 8/7 root 7. I've just written the same thing twice, but this is 8 root 7/7. Okay, and that's C. And now if you plug this back into the original equation of that line that you got, you'll get the final equation, which is this. (22) A and B are points on a circle with center O. CAD is a straight line. Sorry, CAD is a tangent to the circle A. That means that this is 90 degrees. And angle ODA ODA is 32 degrees. Work out angle CAB. Okay, so if we can work out this angle here, well, we can work out this one, because we do 180 degrees, take away this, take away that. So angles in a triangle add to 180. You don't need to give reasons. 90 plus 32 is 122. 180 minus 122 is 58, so this is 58 degrees. And then angles on a straight line again add up to 180, so 180 minus 58 is 122 degrees. And if you notice here, well, this is a point on the radius, this is a point on the center. And BO, or OB, OB is a radius, and OA is also a radius. So OB equals OA. And a triangle where OB equals BA, OA, sorry, where the two sides are exactly the same is an isosceles triangle. And you know that on an isosceles triangle, base angles are equal. That means if we call this angle x, this one is also x. So we know that x add x plus 122 is 180 degrees, because angles in a triangle sum to 180. So we'll get this, take away 122 to get this, divide by 2 to get x is 29. So this here is 29. And we know that 90, this here is also 90, because remember, tangent meets the radius at 90 degrees. So this here is also 90. So I've done this full 90 degree, take away x, which is 29, will give us CAB, which is 61 degrees. Question 23, this is the last question, and this is proving one of the circle theorems. A, B, C are points in the circumference of a circle, center O. AOB is the diameter of the circle. Prove that angle ACB is 90 degrees. Okay, so if you remember the circle theorem here, is angles subtended from the diameter. The angles subtended from the diameter are 90 degrees. Okay, from the circumference that go through the diameter. Okay, and one way that you can, one advice for questions like this, like geometry and proof questions, is if you have a center of a circle, or you have points, if you just connect up random points. So connect this with this, because these are the only ones not connected. Okay, I know that might sound random, but trust me, it helps. It'll give you an idea of where to start. Okay, what I'm going to do is, if I call this x, and then this one y, somehow we'll find an equation to prove that x plus y equals 90 degrees, because this here is 90. Okay, and if you notice here, this is helpful now, because we've got this radius here, and this radius here. Okay, so this length is equal to this length, meaning that these are isosceles triangles. That means base angles are equal to, if this is y, this is also y. And because angles in a triangle sum to 180, y plus y is 2y. 180 take away 2y will give us this angle here. Okay, we'll do the same thing for x. Radius here, that means these two are equal. These two lengths are equal. That means it's an isosceles triangle. So base angles are equal. That's x. This is also x. 180 minus 2x is this. We know that 180 minus 2y, add 180 minus 2x, will give us 180 degrees, because this is a straight line. So add these two together to get this. Simplify to get that. What did I do here? So I added 2y and added 2x to both sides and took away 180 to get this. And I'm only going to divide by 2. Because if I do that, I'll get y plus x is 90 degrees. And that's the answer. That's all you need. Because here, y plus x is 90 degrees. Okay, so we've proven it. So therefore, you can say angle ACB is equal to 90 degrees.